Spring 2020, the Libyan desert became an unexpected laboratory for modern warfare when Turkish Bayraktar TB2 drones systematically dismantled what was supposed to be impenetrable Russian-made Pantsir S-1 air defense systems. Between 9 and 15 of these $15 million platforms were confirmed destroyed, not by stealth fighters or cruise missiles, but by Turkish drones costing roughly $5 million each. The tactical calculus was brutal and deliberate. Turkey had weaponized the concept of attritable platforms, aircraft designed to be expendable, flown into contested airspace, where losing one wouldn't cripple your air campaign. For Western analysts accustomed to preserving every asset, this was doctrinal heresy. Yet, it worked. The Pantsir's radar systems, built to track fast-moving jets, struggled against the TB2's slow, patient approach. By 2022, naval strategists were studying reports that a TB2 had reportedly distracted the radar of the Russian cruiser Moskva, just long enough for Ukrainian Neptune missiles to close the distance. Whether confirmed or not, one fact remained undeniable. A NATO member's indigenous drone had forced global militaries to reconsider integrated air defense from the ground up. But this tactical revolution didn't emerge from nowhere. It was forged by a century-long struggle for aviation sovereignty, a journey that began with salvaged engines and jail time for a World War I ace. To understand why Turkey builds its own aircraft, you need to understand July 1974. Turkish forces landed on Cyprus to protect the Turkish Cypriot population, and within weeks, the United States Congress imposed a full-arms embargo. Turkey's entire air force, F-4 Phantoms, F-1 Hung-4 starfighters, every frontline fighter, was American-built, American-maintained, and suddenly, American-grounded. Spare parts stopped flowing. Maintenance contracts evaporated. A NATO ally discovered it had no operational independence whatsoever. The response was institutional and permanent. In 1975, Turkey established Aselsan to develop military electronics domestically. In 1984, Turkish aerospace industries followed. The doctrine shifted from total NATO integration to what strategists called selective independence, identifying critical choke points in the supply chain and ensuring Turkey controlled them. This wasn't paranoia, it was pattern recognition. Fast forward to 2020, Canada bans export of Wescam MX-15D targeting optics for the TB2 drone. Turkey responds by fielding the indigenous Selfleer 500. The United States blocks Laichtech CTS-800 engine sales, killing Turkey's T-129 attack helicopter export to Pakistan despite a signed contract. Every embargo creates another capability Turkey must develop in-house. It's expensive, it's technically challenging, and it's absolutely necessary, because the alternative is having your Air Force grounded by foreign legislative committees. This sovereignty imperative wasn't new. Turkey's aviation pioneers faced the same challenge a half-century earlier, with even more primitive resources. 1925, Vasihi Hırku, a World War I ace, built Turkey's first indigenous aircraft in a workshop using local timber and fabric. The fuselage was Turkish, the wings were Turkish, but the heart, the power plant, was a salvaged 200-horsepower Benz water-cooled engine pulled from a captured Greek aircraft. The KVI reached 207 kilometers per hour, 112 knots, during its 15-minute maiden flight. Then, Hırku was arrested and jailed for 10 days, not for espionage, not for violating airspace. The Turkish government simply had no one qualified to certify his pilot's license. He eventually had to travel to Czechoslovakia for airworthiness papers. It was the first chapter in Turkey's recurring propulsion crisis. Enter Nuri Demira, an industrialist who understood that aviation required vertical integration. His new 36 trainer used a 150-horsepower Walter Gemma 1 engine, still imported, still a dependency. But his new 38-passenger aircraft was genuinely competitive, a twin-engine design cruising at 271 kilometers per hour, matching the performance of the American Beechcraft Model 18, carrying 4 passengers on domestic routes. Then came the new D-40, often misidentified in historical records as a transport, but actually a twin-engine fighter prototype with a push-pull configuration. Demira's engineers shipped it to Germany for wind tunnel testing at the Eva Göttingen facility in 1938. The data looked promising. Then, World War II erupted, the factory was nationalized, and the new D-40 was scrapped before it ever reached production. The THEC programs, Turkish Aeronautical Association, showed what was possible when engineering ambition met realistic constraints. The THEC-5 ambulance became Turkey's first aircraft export. One unit sold to Denmark in 1951, registered as OYAK, where it served for a full decade. Reliable, practical, unglamorous, exactly what a young aviation industry needed to build credibility. Then, THEC went radical. The THEC-13 flying wing of 1948 was a tailless glider design inspired by the Horten brothers' experimental work in Germany. Turkish test pilots flew this delta-shaped aircraft over Ankara decades before the B-2 Spirit made stealth profiles a household concept. It was visionary. It was also a glider, no engine required, which solved the propulsion problem by eliminating it entirely. These early propulsion constraints weren't solved, they evolved. By the 2000s, Turkey's rotary wing programs faced the same dependency bottleneck, but with stakes measured in combat casualties. The T-129 attack helicopter illustrates both Turkey's technical sophistication and its enduring propulsion vulnerability. Built on the Italian Agusta A129 Mangusta airframe, the T-129 is a heavily modified platform powered by Litec CTS 804A turboshaft engines, 1,373 horsepower each. Why the upgrade? The original Mangusta couldn't handle hot and high operations in the Anatolian mountains where thin air and extreme temperatures degrade engine performance. Turkish engineers reinforced the cockpit with composite Kevlar and boron carbide armor rated to withstand 12.7 mm and 14.5 mm projectiles, the kind of heavy machine gun fire you encounter in mountainous counterinsurgency operations. The T-129 performed exactly as designed. Pakistan signed a contract for 30 units. Then the United States invoked ITAR, International Traffic in Arms Regulations, and blocked the engine export. The deal collapsed. A completed contract, nullified by American regulatory veto. Turkey's response was the T-929 Attack II, a 10-ton heavy attack helicopter designed to compete directly with the AH-64 Apache. Maximum takeoff weight matches the Apache's specifications. Payload capacity hits 1,500 kilograms distributed across 6 hardpoints. But the power plant? Ukrainian Motor-Sich TV317 VMA turboshafts, each producing 2,500 horsepower. Turkey deliberately bypassed American suppliers, accepting the geopolitical risk of Ukrainian dependency to escape ITAR restrictions. The contingency plan is TA's indigenous TS3000 engine, though the integration timeline remains uncertain. Meanwhile, the T-629, a 6-ton platform, serves as a technological testbed, with electric and unmanned variants exploring low-signature operations. It's a transition platform, bridging manned and autonomous rotary systems. While helicopters adapted existing platforms, Turkey's drone revolution started from a clean sheet and changed warfare itself. The Bayraktar TB2's combat record reads like a case study in cost-effective lethality. Libya, 2020, 9-15 Panzer S-1 air defense systems destroyed. Nagorno-Karabakh, same year, extensive armor and artillery kills working alongside Israeli EI Harop loitering munitions. Syria, multi-year deployment data showing sustained operations in contested airspace. Ukraine, 2022 to present, documented naval and ground target engagements that made the TB2 a household name. But here's what matters to procurement officers. The TB2 costs roughly $5 million per unit. The American MQ-9 Reaper costs $32 million. That's a 6-to-1 cost advantage for a platform you're willing to lose. And Turkey had to build that advantage under embargo. The original TB2 used an Austrian Rotax 912 engine, 100 horsepower, perfectly adequate. Then came the embargo. Turkey developed the Thai PD-170 indigenous turbodiesel, 170 horsepower, purpose-built for the mission. The targeting optics, originally Canadian Westcam MX-15D systems. Canada banned export in 2020. Turkey fielded the Aselfler 500 as a replacement. Every sanction created another indigenous subsystem. Now Turkey's pushing the concept further. The Xlelma, unmanned carrier-based fighter designed for the TCG Anadolu. The B variant uses a Ukrainian AI-322F afterburning turbofan targeting Mach 1.2 plus supersonic performance. It's an expendable air superiority platform, a tritable doctrine applied to fighter missions. Then there's the loitering munition portfolio, STM Kargu-2, flagged in a 2021 UN report as potentially the first autonomous human engagement in Libya. Robot Azab with its delta wing design, 500-kilometer range, swarm-capable, Kamunki jet-powered mini-cruise missiles, 100 to 150 kilometers, AI terminal guidance, launched from larger drones like the ANC. These operational systems validate Turkey's doctrine, but the ultimate test of sovereignty is the fifth-generation fighter, a capability only 5 nations possess. The Khan, formerly designated TFX, represents Turkey's ultimate sovereignty gamble, a fifth-generation stealth air superiority fighter comparable in dimensions and mission profile to the F-22 Raptor. The first prototype completed its maiden flight in February 2024. It's an impressive achievement for a nation that 70 years ago was jailing pilots for lacking proper certification. But here's the engineering reality that keeps Turkish defense planners awake. Those prototypes are powered by General Electric F-110 GE-129 afterburning turbofans, the same engines that power the F-16, producing 29,000 pounds force of thrust each. They're stopgap power plants, full fifth-generation capability, supercruise, advanced thrust vectoring, optimized stealth integration, requires the indigenous TF-35000 turbofan, a 35,000-pound thrust-class engine targeted for integration by 2032. That's a high-risk timeline for one of the most complex engineering challenges in modern aerospace. And this is where the sovereignty paradox returns with brutal clarity. You can engineer radar cross-section reduction. You can develop indigenous avionics, weapon systems, even stealth coatings. But if the United States can embargo your engines, your fifth-generation fighter becomes a hangar ornament. Turkey isn't alone in this dependency. South Korea's KF-21 uses the same General Electric F-414 engines, but only 3 nations operate fifth-generation fighters with completely indigenous power plants: the United States, Russia, and China. Everyone else is one export restriction away from a grounded fleet. Look at the historical pattern. Vasihi Herku in 1925, salvaging a Benz engine from a captured Greek aircraft. The T-129 export to Pakistan, blocked by Litek engine restrictions. Now the Khan, betting Turkey's air superiority future on an engine that doesn't yet exist in operational form. If the TF-35000 succeeds, Turkey joins an elite club of complete aviation sovereignty. If it fails, the Khan becomes Turkey's most expensive dependency. The F-35 scenario repeated, but entirely self-inflicted. Yet Turkey's broader impact on military aviation is already secure. The TB2 forced a global reassessment of integrated air defense doctrine. It demonstrated that attritable air power can challenge peer threats. It created an export market for non-aligned nations seeking alternatives to American or Russian platforms. But ultimate sovereignty remains conditional on propulsion independence, the exact same engineering problem Vasihi Herku faced a century ago. The TB2 worked around the problem. The Khan must solve it. History will judge which approach defined Turkey's aviation legacy.